Good morning, students. How are you all? Hope you all are fine and safe. Welcome to the online classes. Today we are going to solve few problems based on work and energy. Are you all ready? If yes, let's start our session. My first question is, all of you, please be ready with paper, notes and pen. Your first problem for today is find the kinetic energy. Find kinetic energy of a road roller whose mass is 400 kg, whose mass is 400 kg, moving at a speed of moving at a speed of moving at a speed of 36 kmph. 36 kmph. I repeat the question. Find the kinetic energy of a road roller whose mass is 400 kg moving with a speed of 36 km per hour. Okay. So you need to find the kinetic energy. First, write down the given data. What are given? Write the kinetic energy formula and solve for the answer. Come on. Waiting for your answers. Make it fast. Shreyas, you need to check your answer. Okay, let's see. Kind of mass is given as 400 kg. Velocity is given as 36 mph. Your kinetic energy formula is half mv square. This is your formula, right? Before substituting the values, make sure that all the quantities are in the same units, either in MKS system or CGS system. Okay, see, mass is in SI units, kg, MKS, K for kg, and M for meter, S for second. Okay, but here it is kilometer per hour. I want in meters. So I need to express this 36 kilometers per hour into meter per second. In order to convert 36 kilometer per hour, yeah. So 36 into 5 by 18 meter per second. Okay, 18 ones, 18 twos. So your velocity is 10 meter per second. Now you substitute the values. Half, mass is 400, velocity is 10, v square, so 10 square. 2 ones to 200, so 200 into 10 square is 100. So your answer is 20,000 joules. So your answer is 20,000 joules. Simple, very simple problem. Okay, kinetic energy formula half mv square, but the twist is here. See, what you people will do is you will directly substitute the 36 kmph as it is, but that's not uh, that should not be done here, because before substituting you should see that all the quantities, whatever quantities are there in your formula, you need to have, I mean, in same units, CGS or MPS, whatever. Okay, so you need to take it. All the things must be in one system. Okay, copy it. Understood? Did you all understand? Did you all understand? Yeah. Okay, let's move on to our second case. Similarly, I don't know what you have done. Once you check your answer. Okay. Coming to the second question. A machine, a machine performs, a machine performs 1440 joules of work. A machine is doing some work of amount 41,440 joules of work in 12 minutes. In 12 minutes. Calculate, calculate the power delivered by machine. I repeat the question. A machine has delivered 1,440 joules of work in 12 minutes. Okay, calculates the power delivered by the machine. Okay, yeah, can you solve the problem? Please solve. Try, first of all, you try. Students, you just don't follow the teacher. You need to think logically, what is the given data, what need to be found, and that all you must solve. That develops your problem solving skills. Okay, try doing it. First of all, he asks you to calculate power. We all know power is nothing but work upon time. Work upon time. Work by time. What is the amount of work? 1440 joules. Okay. So, but before substituting, you should ensure that all the things are in same system, right? So this joules and it is an SI system. Then what about minutes? Time is not in SI system, right? Time must be in seconds. So convert it into seconds. So work is 1440 as it is, but instead of 12 minutes, this instead of minutes, I need to convert it into seconds. So joule per second. Now 0 gets cancelled. Find out 12 ones, 12 ones, 6 ones, 6 twos. So 2 joule per second. Power value is nothing but 2 joule per second. But this joule per second can be written as watt. So 2 watts is your answer. What is the power now? 2 watts. Please copy down. Yeah, let's move on to the next problem. Swati pushes a wooden block kept on a smooth tabletop with a force of 3.515 newtons. Okay, a table is there. On this table, you have one wooden block, and this wooden block is pushed by a person by applying some force. Swati is pushing a wooden block on the table surface. Okay, on the wooden block is on the table, and that is being pushed by your one person with a speed of with a force of 1.5 newtons. So what is given? Force is given as 3.15 newtons. If the book is placed through a distance of 50 centimeters, if that block is displaced to a distance, when you apply force, what happens to the block, children? It will be displaced. This will be moved to here, right? So, what is the distance displaced by this is 50 centimeters. Displacement is given as 50 centimeters along the direction of the force. Okay? In the direction of your force only, the book is moving. So, force direction is like this, and your book is also moving in the same direction. And it has been displaced by 50 centimeters. Now, find the work done by the force. So, here please ask you to calculate work done by the force. Is the question clear for everybody? Shall I repeat the question? A boy is pushing a wooden block which is kept on your table by applying a force of 3.15 newtons. After application of the force, the block has been displaced by 50 centimeters, 50. Then calculate the work done by your force. That's your question. Okay, please calculate work done by the force. Waiting for your answers. Abhinav. Yeah, Abhinav got the correct answer. Work done is nothing but product of force into displacement. Yeah. Sai, we need to check your answer once. So, force is given as 3.15 newtons. S is given as 50 centimeters. Okay. Same story. Whenever you are substituting the values, check whether all the units, all the quantities are in the same system of units. See, Newton is SI unit. Then what about centimeters? It's not, it is in CGS system. So convert it into meters. So how do you convert it into meters? 50 centi means 10 power minus 2 meters, which means 50 by this becomes 10 square if it comes down. So 10 square is nothing but 100. So 50 ones are 52. S is your half meter. Then what happens to your work? Force into S, 3.15 into 1 by 2. 2 ones, 2 ones. Okay, what happens? Calculate. So your answer is 1 point. What do you get? 2 ones, 1 will be left over, 2 fives, then 1 will be left, 2 sevens, 14. Okay, 2 sevens, 14, again 1. So 1.575 is your answer. Yes, Abhinav, right. Understood. Are you all able to do the problems by yourself? Feeling any difficulty? How many are with me? How many are with me? Please, are you all there? Yeah, Deepak Reddy, once check the answer. Only few yes. Why? Only six people are with me. 37 students are with me. I need everybody to concentrate. Yeah, thank you. Coming to the next question. So here, don't forget to write the units. Without units, answer is not, it will not have any value. Okay, let's move on to the next question. An iron safe is pushed. An iron safe is pushed through a distance of 3.2 meters. Through a distance of 3.2 meters. Okay, let us take an iron block. It is pushed. How much displacement when you push? What is the displacement of your iron block? It's 3.2 meters across a floor offering 75 newtons of resistance. When this is pushed, it has been displaced. Here it has come here now. Okay, and the distance, or I mean the displacement here is given as 3.2. But when it is moving across this floor offers some resistance, right? Which we call it as what is the resistance offered by the floor when one body is sliding over the other? Yeah, friction. Very good. Okay, so this resistance offered is given as 75 newtons. That means your frictional force is given as 75 newtons. Here, how much work is done by the resisting force? How much work is done by the resisting force, not the applied force. Resisting force. What is the work done by the resisting force? So, work done by the resisting force is nothing but force into. Nayani, need to check your answer. Force into S. So, force, if you observe this, displacement is happening like this and force is applied in opposite direction. Can I take the value as 75 or minus 75? Please tell me. See, if you observe, the displacement and the force both are in opposite direction. When for F and S are in opposite direction, negative work is said to be done. So your work will be in minus. So W is equal to minus Fs. So minus 75 into 3.2. Calculate the answer. It's 240 joules. So this minus indicates negative work is done here. Is it okay for everybody? Yeah. Let's move on to the next problem. Please copy the table. I will give you one table. This is force. Fifty, 30, 60, 100. This is in newtons. Next, displacement. Displacement. Yes. This is in meters. Values are 2, 5, 4. This is important. Please, angle between F and S. Angle between F and S. 0 degrees, 90 degrees, 180 degrees, then 0 degrees. This is your given data. All of you, is it clear for everybody? Please try to copy the table. Please try to copy the table, all of you. See here, the angle between F and S is given. Sometimes, okay, first try to copy this, afterwards I'll explain. If you are done, please let me know. The blocks are given, things are case, force, displacement, angle between F and S. You have 4 cases, force 50, 30, 60, 100, displacement 2, 5, 4, 0, and the angle between F and S, it is very important, 0 degrees, 90 degrees, 180 degrees, 0 degrees. Okay, I'll rub it now. It's you will get for 4 months for informative skills. For that, it is very useful. So, your question is, answer the following questions. Your first question is, in which of the cases work done is 0? Second one is, in which of the cases work done is negative? Third one, in which of the case calculate work done in case 1. Fourth one, in which of the cases work done is positive? Are the questions clear for everybody? From the above table, you need to say in which cases work done is 0, in which cases negative work is done, in which cases positive work is done, and in case 1, what is the work done? These are the 4 questions. So each 4 questions will carry 1 mark. You can expect it in the 4 marks. Okay, now let's see. Here it's not simple like W is equal to Fs. Till now we were using this formula, right? But for example, a girl holding a toy car, and she is moving like this. She is dragging the toy car. When she is dragging the toy car is moving in this direction. But in which direction the force is applied, children? She is applying, pulling it in this direction, right? This is your force. This is your displacement. In this case, force and displacement, in between them, there is an angle between them, right? Okay, so what is the work done when there is some angle between F and S is work is defined as Fs cos theta. Fs cos theta. Now you find out when is the zero case. First case, you see, first case work done is nothing but 50 into force is given as 50 in first case, displacement is given as 2 and cos 0. Cos 0. What is cos 0? Cos 0. So cos 0 is 1. So 52 is 100 joules. Okay. Understood. So in this way, you need to find out for all the four cases. Try to find out. It is your homework problem. Try solving all these. Okay. For four of the things you find out work. In which case you are getting positive. In which case you are getting negative. In which case you are getting work done as 0. Okay. You find it. Is it okay? Any doubts? So I'll end the session, the last 10 minutes. Please try to ask doubts if you have any. Yeah, please try to tell me. Now, please do it. Can you tell me in which case you got negative? Sorry, 0. When 0 work is done, please answer me in the chat box.